This tutorial covers the essential steps to set up a Near Protocol validator node. Install software prerequisites. Prepare your system with the necessary tools and dependencies. Install Near Protocol node. Download and configure the core Near node software. Download a Near Protocol snapshot. Speed up synchronization by downloading the latest network snapshot. Sync your Near node. Connect and synchronize your node with the Near Protocol network. Set up a systemd service. Ensure your node runs reliably by configuring it as a systemd service. Check node logs. Monitor performance and troubleshoot using log files. As we continue with our installation process, we will be using the official Near documentation as our guide. First, we will update and upgrade Ubuntu. Ubuntu is a popular user-friendly Linux-based operating system. We need to update it to ensure the system has the latest security patches and performance improvements, which are essential for running a reliable validator node. We are installing some developer tools, which are essential software packages that help us compile, debug, and manage code efficiently on our system. We encountered an issue with Python, so we removed it to proceed with the installation. Now we're reinstalling Python, this time using Python 3. Installing it separately ensures that it's set up correctly and avoids any conflicts. We can set the configuration, which involves adjusting system or application settings to ensure everything runs according to specific requirements. We are setting up the build environment, which includes the necessary tools and libraries to compile and run software on our system. Next, we install Rust and Cargo. Rust is a programming language focused on safety and performance, and Cargo is its package manager, used for downloading and managing Rust dependencies. We select one to proceed with the standard installation. Here we are sourcing the environment, which means loading the configuration settings or variables into the current session, so the system can recognize and use them without needing a reboot. We will clone the Near core repository, which involves downloading the latest Near blockchain core code to our local machine so we can work with it directly. Ensure that when you check out it is the correct version you need. Next, we compile the Near core binary, which means transforming the source code we downloaded into an executable program that can run on our system. We check to see where the binary is built and check the version. Now, we initialize the working directory. We also need to replace network with testnet to set up the environment for testing. In this directory, you can find the .near folder, and if we enter it, we'll see the Genesis and node key files. You'll notice that there isn't a data folder, indicating that we haven't yet downloaded any Near blockchain data. For our next step, we will create a screen session to download a snapshot. This will allow us to run the download process in the background, ensuring it continues even if our connection drops or we get disconnected from the terminal, allowing for uninterrupted progress. To exit the screen, press Ctrl, A, and D at the same time. Start by creating a screen session. We need to install AWS CLI before we can download the snapshot. Now we download the snapshot. Remember to change your commands to match the testnet so that you download the correct snapshot. We can see that a data folder has now been created. Notice that we have detached from the previous screen. Now, we'll return to the screen session to check on the progress of the snapshot download. Since it's still in progress, we'll exit the screen session and check back later. This time, when we return to the screen session, we can see that the snapshot has finished downloading. Now, we can proceed by running the command to start our node. If you encounter these errors in the logs during the node syncing process, there's no need to worry, it is expected. Simply let the node continue syncing and check back at a later time. After waiting a few hours, we return to the screen session and see that the node is now fully synced. This is how the logs should look with no errors. Now, we stop the node and exit the screen session to set up the service to run using systemd, which is a system and service manager in Linux. It helps manage processes and ensures services like the node runs automatically and stays active in the background. We start the service and check the status. We can see that the service is active. We will enable the service to reload its configuration files without stopping and restarting the service entirely. This means that it will automatically restart if the OS restarts. Let's take a look at the logs. The logs seem a bit monotonous in a single color, so we'll install this package. After that, we'll run the journal command again with the new package to add some color, making the logs more visually clear and easier to follow. That concludes our tutorial on setting up a NIR validator. Join us in the next video, where we'll walk you through setting up a NIR staking pool.